Just a really quick little provocative discussion. I'm not a big fan of the term links in a chain because you've all heard the expression accidents are links in a chain, which imply that all you have to do to prevent an accident is remove one link. And by that model, all links are equal. As long as you break the chain, it doesn't matter. You've stopped the event from happening. That's rarely the way things really happen, and I'll explain that in just a second. Jim Reason came up with this in 1995, which I'm a big fan of Jim Reason's, but I have to tell you, even Jim says, look, don't take the Swiss cheese model too seriously. It's just a metaphor. I would say to you, if the world is filled with holes in Swiss cheese, what's the solution? And the only answer is, well, you fill the holes in the cheese. And I would say, yeah, but what if you can't see all the holes in the cheese? But by the way, you're going to run out of money and resources before you plug all the holes in the cheese. Healthcare is notable in that they try to achieve success in a lot of ways through emulation. They take success stories in certain industries like aviation and the use of checklist, Lean Six Sigma, which came out of the manufacturing industries, and Toyota as one of the leaders in quality. They point to aircraft carriers. And so I'll go into a hospital and they'll say, oh, yeah, I know people that actually have made the trip to Japan to bow at the altar of Edwards Deming and sit down and learn the Toyota methodology. And they come back to hospitals. And I was speaking to one hospital COO, and I told her, I said, well, okay, so you saw a production line, yes, and you saw a cord where anyone on the production line could stop the line. They call it stop the line by pulling the cord. I said, show me where that cord is in your hospital. And she looked at me and said, what do you mean? I said, well, you learned all of the methodologies. Let's just take that one element where every employee is empowered to stop the line. Show me where that cord is in the hospital. And she, of course, she couldn't do it. And it's like, well, it's a metaphor. I said, well, yeah, a lot of things we describe are metaphors. But let's be specific on why the cord works in the automobile manufacturing industry, stopping the line. When you have a production where you have equipment moving in a linear fashion and employees being the quality control of that line, it makes sense to have a button to stop it, or if someone is going to be injured, perhaps they have something caught in a conveyor belt. All of those are engineering design features. The problem is that in the nuclear industry or in the energy sectors and clearly in aviation and manufacturing, it's filled with engineers who understand engineering principles. When you move into healthcare, where the dominant science in healthcare is not the engineering sciences, it's medical science. And medical science has evolved in a very different way than the engineering and aviation sciences. So when I go speak to a COO in healthcare, rarely do you see someone that understands the principles of barriers, redundancies, and recovery features, which are just classic engineering terms. They understand the language of business or they understand the science of medicine, but it's a very different approach. So I guess my point is that when you take something from one industry and stick it into another, expecting the same or similar results, you're more than often going to be disappointed, which is exactly what we've seen in healthcare, where they've tried to emulate some of these other successes that they've seen in other industries. In order to manage a risk of any type, we must see and understand it. We must see and understand it. It's not enough to see a risk. You really have to understand it in order to be able to manage it. So what we want to be able to do is predict where systems may fail and manage them accordingly. Now, to do that, we have to understand a basic principle of reliability, which is systems, reliable systems have two features or two characteristics. They are effective in doing what they're designed to do, and they are resilient when things go wrong. Effective and resilient, two separate features. All right. Now, to do that, engineers know there are features called barriers, redundancies, recoveries. We combine those strategies in cumulative ways to provide what the engineering people would call defense in depth, or how we build system effectiveness and resiliency. Those are features that we have to understand. Okay, so I told a story some time ago. I'll retell it today. It's another healthcare story. A patient in a cardiac ward in a Boston hospital about 12 years ago died. And what happened was the cardiac patient at bedside, an alarm starts sounding. A nurse walking down the hall hears the alarm. And oh, by the way, in healthcare, they have something that we call alarm fatigue, where there's so many alarms that they're very commonly overridden or silenced because there's too many alarms going on at once. This nurse goes to the bedside. She wasn't sure which device was sounding, so by process of elimination, she turned off one device after another, off and on, to see if she could stop the alarm. She went to the cardiac monitor. She turned it off. The alarm kept sounding. She finally found it was an infusion pump, which pumps medication in intravenously. It had become occluded. She reset it, stopped the occlusion, turned it back on. The alarm went away. Problem solved. She went back to the hallway to go treat other patients, but she forgot to turn the cardiac monitor back on that she had first turned off. Human error, right? So she goes down the hallway. Sometime later, the cardiac patient, went into cardiac arrest and died, and no one on the floor knew because the cardiac monitor alarm did not sound. The Joint Commission came in and did a big investigation. The Boston Globe got wind of this. The Boston Globe sat down with the patient safety officer, one of our clients, Greg Meyer. He was the chief safety officer at the time at this hospital. And they interviewed him, and the Boston Globe reporter said, ask a series of questions, and ended with this question: have you fired the nurse who caused the patient's death? And Dr. Meyer said, no, because we don't consider that to be the right response. Now, we could, but what we see is this is a combination of a system, a patient, and a caregiver. That's called a socio-technical system. If we fire the human who is closest to the scene of the impact, what chance do we have of other nurses reporting the same behavior or the same human errors? So at my urging, Dr. Meyer went back to the manufacturer of the cardiac monitor alarm and asked a very simple question. He said, can you redesign this cardiac monitor such that if someone turns it off and it is working properly, if it's functioning properly, and someone turns it off either by mistake or with intention, that it can reboot itself and come back on? And what do you think the engineers said? Of course, we didn't know you wanted us to do that. Engineers actually don't think like real humans, do they? Sometimes engineers are very geeky. They don't understand why us humans don't operate the machinery or the equipment the way it was designed. So the engineers, not thinking like a nurse, said, why would you turn it off? They didn't anticipate the human fallibility in the equation. So was that cardiac monitor alarm highly reliable? No, it was effective when it was turned on and connected to the patient. It was not resilient when a nurse turns it off, either with intention or by human error. Again, we have to look at systems differently. We have to not think of them solely in terms of how they perform mechanically or electromechanically or digitally. We have to learn how they perform in combination with the people that are actually operating the equipment. I'm going to ask a question of you. I'm going to just take one moment here. And the answer to this should be obvious, but it's something that it's good to reflect on. Highly reliable organizations must be good at A, seeing and understanding risk, B, managing systems, C, managing people, and D, sustaining organizational improvement. Now, the obvious answer here is E, all of the above in sequence. Now, what I would ask you to ask yourself introspectively is, where do you put your focus in the job that you do?